Hi, I'm Professor Goings. In this video, I want to take a look at finding what's called a difference quotient. You'll see this in a couple of different places. You'll see this in a pre-calculus class, in some exercises where you're learning about function notation. You'll also see this in a calculus course where if you are required to find the derivative of a function using the limit definition. You'll also see it in maybe a Calc 3 class when you're looking at partial derivatives. You might start by defining it using a difference quotient. But there's a variety of courses where you will see that. Okay, let's look at the following graph, this red graph here of f of x, and I want to look at a particular secant line. In particular, I want to look at the secant line passing through the points corresponding to an arbitrary x, and then somewhere to the right, say x plus h. So of course, in this case, h would be positive. That gives me this point on the line, this point on the graph, this point on the graph that generates a line, and the y values corresponding to this would be f of x here, and then for x plus h, that would be f of x plus h. Slope of the secant line, of course, is the change in the y divided by the change in the x. The change in the y would be the change in these two values, which would be f of x plus h minus f of x. And the change in the x values would be x plus h minus x. And that denominator, the x's cancel, giving me f of x plus h minus f of x all over h. And this expression right here is the difference quotient. Geometrically, what it represents is the slope of a secant line. In your pre-calc class, you'll just work with finding difference quotients. You won't really put any geometric ideas to it, and you certainly won't do anything with the h value. In your calculus class, like I said, when you do the limit of a difference quotient for your definition of the derivative, this will be the algebraic portion of that computation. We'll be simplifying those. So what I want to do is go through a variety of types of functions and find their difference quotients. Look at the different types of algebraic maneuvers that might be required. For example, find the difference quotient. Part A, let's start with a quadratic function. Let's start with x squared plus 3x minus 7. Part B, let's use a rational function. Let's say f of x is x divided by x plus 4. And then for part C, let's use a radical function. So let's take a look at the square root of x plus 3. Solution. I want to find the difference quotient of that. It's always a good idea to start by writing the general expression. A lot of times when people make mistakes with difference quotients, it occurs right here at the very first step. So let's go through this carefully. The first part of this is I take x plus h as my input and plug that into f. For this function here, f, where do the inputs go? The inputs go in the place of x. So x is your placeholder for the inputs. Meaning x plus h, that term is going to go both here under the square and here after the 3. Let me write just that term and let's make sure we see that. F of x plus h would be, oh, and I already started writing it wrong. F of x plus h would be x plus h squared plus 3 times x plus h minus 7. this right here is f of x plus h. Once again, make sure you see that I take the original function f and I plug in x plus h. X plus h is my input. Inputs go under the square and after the 3. So x plus h goes under the square and then after the 3. Next part is to subtract f of x. That says I'm going to subtract x squared plus 3x minus 7. And I'm subtracting all those terms, so I have to make sure I group those together, and then the whole thing is divided by h. There's the setup, and then from here we just have to simplify that. In order to simplify that, what I'm going to do is I'll expand this term, so I'll FOIL that, distribute 3 through this grouping symbol, and then I'll distribute a negative through that. So it'll give me a bunch of terms. If I FOIL x plus h squared, I'm going to get x squared plus 2xh plus h squared. Distribute 3 through this grouping symbol here, I get plus 3x plus 3h minus 7. And I think that'll be off screen if I do it over here, so let me put this down below here, but this is still all part of the numerator. Then I would have minus x squared minus 3x plus 7. And those two lines again incorporate the numerator, and then that's all divided by h. I expand it as much as I possibly can, and then what I'll do is I'll see what I can cancel. You'll have a bunch of terms that will disappear. Look at the terms up there in the numerator, and you should see a variety of terms that have the same term, just opposite signs, so plus and minus. Certainly we can see there's a positive 7 and a negative 7, and then we can see that there is a negative 3x and a positive 3x, and then there is a negative x squared with a positive x squared. Most of the terms then will just, especially for polynomials, will just cancel. Okay? Now let's rewrite this and clean up what we have. My numerator now consists of 2xh plus h squared plus 3h, so that would be this term, and this term. Those are the only ones that are left, divided by h. If I look at this expression here, I can simplify it one step further. Every term in the numerator has a factor of h, meaning I can factor it out. Then common factors cancel. That h cancels with that h, giving me the final answer of 2x plus h plus 3. So this would be your difference quotient for that quadratic. Let me clean this up, and then we will take a look at finding the difference quotient of this rational function. Same thing at the beginning, I'm going to write the general expression for a difference quotient, and that will help me with the formatting for using this function here. All right, for f of x plus h, remember x plus h is your input. The inputs go where x is, so I'm going to replace this x and this x here with x plus h. That will give me x plus h divided by x plus h plus 4. So this right here is f of x plus h. So once again, it's x plus h is my input plugged into the function f. For the function f, inputs go in both of those two x locations. Minus the original function, so minus x over x plus 4. and then it's that whole thing divided by h. This then is what we then need to simplify. To simplify that, what I'll do is I'll start by combining these two terms up here so that they have a common denominator. Let's just start by putting in our formatting. The common denominator between this term and this term would be just the product of their denominators. That would be x plus 4 times x plus h plus 4. In order to keep this fraction balanced, whatever factor I put in the bottom, I'm also going to have to put on top. I already had an x plus h there, and I put in a factor of x plus 4 in the bottom, so I have to have both of those factors on top. Over here, I had an x already, and I put in the factor of x plus h plus 4. Okay. What I'm then going to do is these two terms can go under the same denominator. So this denominator match, so I can just combine the numerators. And then I can also take this h, which is under this the gigantic fraction bar, I can make that h over 1 and then flip and multiply. What that then gives me is a denominator of h times x plus 4 times x plus h plus 4. These denominators match, so that's going to be my common denominator between these two. This h becomes h over 1. I flip and multiply, so that gives me a factor of h there. And then for my numerator, I'm going to have this product minus this product. Okay. For this first product here, we FOIL that. That would give me x squared plus xh plus 4x plus 4h. So that would be the product of these two terms. Then I'm going to subtract this product. Means I take x and distribute it through. That would give me x squared. Remember, I'm subtracting all of these, so I'll distribute the negative through as well. So I've got a negative x squared. Then I have xh, giving me a minus xh. Then I have a minus 4x. And we can see what will cancel. All right, x squared cancels with minus x squared. Positive 4x cancels with minus 4x. Positive xh cancels with minus xh. Once again, we have a lot of cancellations. Let's clean that up and see what we have left. My whole numerator consists of only the term 4h. My denominator consists of h, and then x plus 4, x plus h plus 4. Just like over here, we then have a common denominator, a factor on top and bottom, so a common factor will cancel. That means this h here will cancel with this h here, giving me my final answer of 4 over the product x plus 4, x plus h plus 4. So that would be the difference quotient of this function. Let's go through part C. For this one, f of x plus h would be the square root of x plus h plus 3 minus the square root of x plus 3 all over h. So we then have to figure out what sort of algebraic maneuvers can we do with this. And the previous two examples, we saw the same thing happen near the end where the h in the denominator, the original h here, cancels. And that's the motivation for simplifying this expression here, is I want to do something to this so that I can cancel this h. Okay, whenever I'm doing a difference quotient of some sort of an algebraic function, whether it's a polynomial, rational, radical, something along those lines, I always want to be able to cancel this h. That's as far as I want to take the simplification, and that's my goal, which again, you'll see why when you take your calculus course, in your Calc 1 course, if you happen to be watching this and you're a pre-calc student. Okay, what I need to do then, let's see if we can figure out how this would work. How can I cancel this h? Well, I'd like to be able to, so if I look back over here, we were able to cancel the h because I had a common factor of h, which is what we did here and here. Same thing in the previous example. Cancel the h in the denominator with a common factor. Ideally, I somehow want to get at this h right here, so that would give me a common factor. And also notice something. If, let's just ignore the radicals for a moment. If I look at this radicand and I look at this radicand and I were to subtract those, notice I would be left with just an h. So that's my motivation. I want to figure out how can I somehow subtract those radicands. What can I do to eliminate the radicals? Well, there's a standard technique for eliminating radicals called rationalizing. What I'm going to do is I'm going to multiply by the conjugate of this. All right, so I'm going to multiply top and bottom by the conjugate. We'll see how far I can go over on the, let me write this a little bit smaller to try to make sure it's on screen. Okay, the conjugate is this expression. I just changed the sign in the middle. That would give me x plus h plus 3 plus the square root of x plus 3. So my apologies if that's hard to read, if that's small. I should have started this a little bit farther over, so that's my fault. This right here is the same thing as the black expression. I just changed the sign in the middle. And of course, if I'm going to do that to the top, I have to do the same thing to the bottom. What I'm going to do is I'm going to multiply the conjugate pair. So I'm going to multiply the numerator and I'll leave the denominator alone, keeping in mind that I eventually want to cancel this h. So I'm going to leave it as a common factor. I'm going to leave it as a factor in the bottom. All right, let's start over here. What I'm going to do is let's start by writing the denominator. I've got h times square root x plus h plus 3 plus the square root of x plus 3. Now the numerator is going to be quite messy, but it's going to collapse as we will see. All right, when I FOIL this, first terms would give me the square root of x plus h plus 3 squared, so there's the f part of FOIL. Then for the outside terms, I would get the square root x plus h plus 3 times the square root of x plus 3. Then the inside terms would give me minus the square root of x plus 3 times the square root of x plus h plus 3. Didn't make my fraction bar nearly long enough. And then finally minus the last term, which is the square root of x plus 3 and then quantity squared. I warned you that was going to be quite messy. But I also said that it was going to absolutely collapse. Stare at that for a moment, pause the video, and see what that's going to reduce to. Well, what you can see is that the two middle terms cancel. This whole term and this whole term cancels because they're additive inverses. The very first term, I've got a square of a square root, so that radical and that square cancel. The very last term, that radical and that square cancel. More cancels, but let's write what we have so far. I've got the first radicand, x plus h plus 3, minus the second radicand of x plus 3. You remember I mentioned that was a goal. What if we could just subtract those two radicands? Well, that's exactly what we accomplished. And then for my denominator, I've got the square root x plus h plus 3 plus the square root of x plus 3. And you can see in that numerator then, the x's cancel, the 3's cancel, the only thing left is the h. If the only thing left on top is h, and I've got an h over h, those would then cancel. And your final answer would be 1 divided by the square root of x plus h plus 3 plus the square root of x plus 3. And this would be your difference quotient of the function square root of x plus 3.